Find x. There it is. Ah-ha-ha! This is a right triangle, and we are being asked to find the missing side of a right triangle. And whenever you're being asked to find the missing side of a right triangle, you use a little old guy called Pythagorean Theorem. A squared plus b squared equals c squared. Now, what's what? Well, to be honest, it doesn't matter which one A or B is, as long as your longest side is C. C is the hypotenuse. C is always going to be the side not attached to your right angle. So C has to be 13 in this case. Which one has to be A or B? It doesn't matter as long as the longest side is C. So I'll call A 12 and I'll call B X. Now you substitute these numbers and that variable in here and do a little bit of solving. A is 12, so 12 squared, plus b is x, so x squared, equals c is 13, so 13 squared. Now the next thing that you do in Pythagorean Theorem is you simplify the numbers. So 12 squared is 114, plus x squared is still x squared, and 13 squared is 169. In order to get x all by itself, I have to subtract 144 from both sides. So minus 144, minus 144, cross you out, drop down the positive x squared, equals, and 169 minus 144 is 25. Now squared is in the way. I have to find x, not x squared. How do I undo a squared? Square root both sides. Now you may have learned in the past that whenever you take the square root of both sides to solve, you have to attach one of these guys, a positive or a negative symbol to the number, but we don't do that here. Why? Because we're finding the missing side of a triangle. So you're not going to say, my answer is positive or negative. Well, you can't have a negative side, so it can't be or negative. So my answer in this case is just positive 5. Now, since I'm given a unit of measure, I'm going to make sure I attach that in my answer. So find x. X is 5 inches. And that's my answer. We're done. Find x. We are being asked to find the missing side of a right triangle. Whenever I'm asked to find the missing side of a right triangle, we use this fella, the Pythagorean Theorem, invented by Pythagoras way back in the day. Now, a squared, b squared, and c squared, they are all representative of 3 sides here. Now, what letter gets what? Well, C has to be the hypotenuse, the longest side. The hypotenuse is always going to be the guy not attached to your right angle. Which one's A, which one's B? It doesn't matter as long as the longest side is C. So we'll call A 4, we'll call B 3, and we'll call C X. Now I plug them into the formula. A I called 4 squared. A fun game to play. B I called 3, so 3 squared, and C is x squared. Whenever you're doing the Pythagorean Theorem, whether it's you're finding a missing hypotenuse or a missing leg, the second step is always to simplify these numbers. 4 squared is 16, plus 3 squared is 9, still equals x squared. If you can combine like terms, combine them. 16 plus 9 is 25. 25 equals x squared. Now, I didn't find x yet. I have x squared. And in order to get rid of that squared, I have to square root both sides. Now, in the past, you were taught that if you take the square root of both sides in order to solve, you attach a positive or negative symbol to the number. We don't do that here because we can have a positive or negative side length. You can't have negative side lengths. It's only going to be positive. So we're not going to attach that symbol. So I'm sorry I even brought it up. But the square root of 25 is 5. The square root of x squared makes it just x. And what I'm going to do is I'm going to flip it around because I like my variable on the left, x equals 5. And I'm going to make sure I attach the unit of measure, which is miles in this case, because it's proper. But You are asked to find the missing hypotenuse. And in this case, finding the missing hypotenuse is Pythagorean Theorem, combine like terms, square root, you get 5 miles. I would walk 500 of those to answer another problem. It's a song, look it up. All right, find the missing height. We have ourselves a right triangle. Anytime you're trying to find the missing height of a right triangle, use Pythagorean Theorem. Always make sure that C is the longest side. It doesn't matter which one is A or B as long as the longest side is C. So this is going to be 35 squared plus h squared equals 50 squared. 35 squared is 1,225. H squared is h squared. 50 squared is 2,500. Subtract 1,225 from both sides. When you do that, you end up with 1,275. To get rid of the squared, you have to square root both sides. When you do that, you get yourself not too pleasant number, but it ends up working out 35.70 blah, blah, blah. So we'll just leave it at that. So 35.7 feet. State if each triangle is a right triangle. This uses a little thing called the converse of the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Usually we use this guy to find missing sides of right triangles. Well, in all three of these cases, I'm given all three sides. So what I have to do is use this guy to make sure that these are right triangles. Now, what does that look like? I go to one of my triangles and I label the three sides A, B, and C. But oh, do be careful, because whenever you label A, B, and C, you must call the longest side C, because the longest side would be the hypotenuse in this case. It doesn't matter which one A is. It doesn't matter which one B is. And what you do, now that we have things labeled, is you plug it into this formula. So A squared is 12 squared plus B squared is 9 squared equals C squared is 15 squared. And you might be thinking, what are we solving for? Nothing. The goal of using the converse of the Pythagorean theorem is to make sure our math works out. If it does, it's a right triangle because it works for the Pythagorean theorem. If it doesn't, it's not a right triangle. It's still a triangle, but it's not a right triangle. So let's do the math. 12 squared is 144. 9 squared is 81. 15 squared is 225. 144 plus 81 is 225. Does 225 equal 225? Last time I checked, yes, it does. So this first one is a right triangle. Okay, let's try it again and again. So I have to label A, B, and C. Which one has to be A, B, or C? Well, A and B doesn't matter as long as you call the longest side C. So I'll call you A and I'll call you B. So 10 squared plus 49.5 squared has to equal 50.5 squared. 10 squared is 100. 49.5 squared is, let me do the math in my head, 2,450.5. And 50.5 squared is 2,550.25. I meant to put a 2 here. I don't know if I said it and just typed it or wrote it out wrong, but there you go. So, okay. 100 plus 2,400 blah is 2,500 blah. That equals 2,550.25. So since the both of them equal each other, even though I have a little writing errors here, I fixed it, and yes, it does work out. Okay, so not as pleasant, but you know, I did the math in my head. I did. Last one. Now, I don't know what the square root of 115 is, but I do know that the square root of 121, which is 11, is 11. So this has to be C here because 11 is going to be bigger than the square root of 115 because 121 is 11. So I'll call you A, I'll call you B, and I'll set it up. And you might be thinking, oh, no, square roots. Don't worry about it. It's actually not bad. I have 9 squared plus the square root of 115 squared has to equal 11 squared. 9 squared is 81. 115 squared cancels each other out if I square root it. Happy days. 11 squared is 121. 81 plus 115 is like 196 or something, which is certainly not 121. So nope, nope. All right, so this is how you use the converse of the Pythagorean theorem. I give you 3 sides. I ask you, is this a right triangle? You determine which one has to be C, and the longest one's always going to be C. You plug it in, you make sure it works, and if it does, it's a right triangle. If it does, if it's a right triangle. If it doesn't, it's not a right triangle. Not bad. State if the triangle is acute, like me, obtuse, or right. We know that we could use the Pythagorean theorem converse to determine if something is a right triangle by saying a squared plus b squared equals c squared. That's how you know if something's right. But how do you know if something is acute or obtuse? Well, if you take the sum of the 2 smaller sides, and that's what A and B represent, square them, if that sum is greater than C squared, you have yourself an acute triangle. Similarly, if I were to take the smaller sides and square them and add them together, and the sum of those is smaller than C squared, you have yourself an obtuse triangle. So I have to look at these, and I'm going to say that you're my A and you're my B. And if you're like, whoa, how did you figure that out? A and B doesn't matter as long as you call the longest side C. So I'm going to say, let me get a color I haven't used yet, 9.6 squared plus 18 squared is, I don't know, 20.1 squared. Once I find out that I don't know, I'm in great shape. 9.6 squared is 92.16. 18 squared is 324. And that is going to be 404.01 for 20.1 squared. If I add these two together, I get 415.16. 416.16. Yeah, that would make sense. And 416.16 is greater than 404.01. So since the sum of the 2 smaller sides was greater than the longest side squared, I have an acute triangle, which means all 3 angles are less than 90 degrees. Kind of tricky, but when you break this all down, you can kind of be like, oh, okay, I see what that guy did there. Find the area of this triangle right here. Well, the area of a triangle is 1/2 of base times height. I have a base, but you know what I don't have? I don't have a height. So what I can do is I can realize that this is an isosceles triangle, boom, boom, boom. And if it's an isosceles triangle, that means the height is going to go directly down the middle. So why don't I cross you out and say that one of these triangles right here is going to be 4.8. Nope, 3.8. 3.8. 3.8. Okay. So how can I find that height? I'll call you H. Well, if I split this big triangle into 2, smaller triangles, I now have a right triangle. And if I'm trying to find the missing side of a right triangle, I use an old friend called Pythagorean Theorem. A squared plus b squared equals c squared. I'm going to call you C because you represent the hypotenuse of this right triangle right here. I'll call you A and I'll call you B because it really doesn't matter which one's A or B as long as you call the hypotenuse C. So I'm going to call A H, so H for my height squared, plus B, which is 3.8 squared, is going to equal C, which is 5 squared. 3.8 squared is 14.44, so I will write that out. That's going to equal 5 squared, which is 25. In order to get h all by itself, I have to subtract 14.44 from both sides, so minus 14.44. Drop down the h squared, and that's going to give us 10.56. Now, in order to get squared all by itself, I have to square root it. Not squared all by itself. In order to get rid of squared, I have to square root both sides. So that crosses out. I'm dealing with triangles, so I don't have to worry about this symbol right here. I've talked about that in previous videos, and if you're like, what? Never mind. I don't know what the square root of 10.56 is, so I'm going to go off to the side and ask my phone. And it's awful. So it's 249615 blah blah blah. So I'll do 3.25. I think that should do it. If it's 3.296, I think 3.25 should do it. 3.2496, that should do it. So that represents the height of my triangle. So let's get rid of all this stuff now that I've gotten rid of it. Okay. What do I know? Well, I now know my height is 3.25. Ish. I have my height. I have my base. Let's plug it all into the formula. A equals 1/2 of my base, which is 7.6, times my height, which is 3.25. I have zero clue what this is off the top of my head, so I'm going to go off to the side and ask my phone again. And the old phone says 12.35. So I'm not going to circle that. Most teachers would be fine with it, but I'm going to say my area is 12.35. I look up here for units. I don't have any, so I will say units squared because whenever you're given area, you should give some type of unit, even if you're not given a unit. And when you're finding area, it's always units squared, feet squared, inches squared, whatever. Okay, but that's how we find the area using Pythagorean Theorem. Find the perimeter of the larger triangle. All right, let's see. I have 42, 26. This chunk is 11, but I don't have that part right there. Well, what I have is I have two right triangles inside a larger right triangle. Maybe this might not even be right. Who knows? It may not be. It doesn't matter. All I know is that this is a right triangle. That's a right triangle. So what I can do is I can find this missing side right here by using Pythagorean Theorem. Once I find that missing side, I could use Pythagorean Theorem again to find that guy. Add all four of these sides up, and I have myself my perimeter. So let's do that. Let's find this missing side right here using Pythagorean Theorem. Let's give it a name. Let's call it H because it's the height of this triangle. That way, when I use Pythagorean Theorem twice, I'm not super confused with the letters that I used. So I am going to use Pythagorean Theorem. A squared plus b squared equals c squared. Now, looking at this triangle right here, this little one with h11 and 26, I know c has to be my 26 because c always has to be the longest side, the side opposite of my right triangle. It doesn't matter which one's a or b as long as the longest side is c. So a is h squared, so h squared plus b is 11, so 11 squared is going to equal c, which is 26, so 26 squared. H squared doesn't change. 11 squared is 121. That's going to equal 676. Now, in order to get H all by itself, I have to get rid of squared and I have to get rid of minus or a regular 121. And I do that by minusing 121. I was getting ahead of myself. Got excited there. So let's subtract 121 from both sides. H squared is going to equal 555. Square root both sides. And I have zero clue what the square root of 555 is, so I'm going to go off to the side and do that. So it's gross, and I knew it would be gross. That's kind of why I took a moment to figure out what this was, because I thought I was going to get something pleasant, and I didn't at all. It's 23.558, so let's go with 23.56. So this guy is 23.56. All right. That guy, the height. Yippee. Now, I'm going to do the same exact thing to find out this part right here. So I'm just going to call it X. All right. I am now focusing on this triangle on the left where I have a height of 23.56. I have a hypotenuse of 42, and I'm missing a length of X. So I'm going to use Pythagorean Theorem again. Using different colors so I don't mix the two A, B's, and C's. I will call you A again because, why not? I'll call you B as long as I call the longest side C. So A is 32.56, 23.56 squared. Plus B is, X squared equals 42 squared. Before you reach for a calculator, we know what 23.56 squared is. It's 555. We just did that. Oh, yeah. Plus X squared is going to equal 42 squared, which is 1,764. Subtract 555 from both sides. Subtract 555 from both sides, and you're looking at 9, carry the 1, make that a 2, 1209. Gross is equal to X squared. Is X all by itself? No. Squared's in the way, so let's square root both sides. No clue what the square root of 1209 is, so I'm going to go off to the side. It's gross. It's 34.7706777301. So I'll put 34.77. So this guy right here, and I'll make it black, is 34.77. So in order for me to find the perimeter of this whole triangle, I have to add that side plus 26 plus 11 plus 34.77. 42 plus 26 plus 11 plus 34.77. That's going to end up equaling 113.77. No units to worry about, so units, feet, inches, whatever. Just don't square it because we're not finding area, we're finding perimeter. Pretty gross problem. Not a big fan, took a while, but yeah, I got it. I got it good. Find the missing side lengths. So with this problem, we are going to use special triangles. Those of you who are like, I did geometry already and I'm using this as a refresher course, don't do trigonometry here. And if you've never taken trigonometry before and you're like, the heck? Then we're going to use what's called special triangles. There's two types of special triangles, but the one we're going to focus on right now is the 30, 60, 90 triangle. The 30, 60, 90 triangle is named 30, 60, 90 because it has measures of 30 degrees, 60 degrees, and 90 degrees. When you're doing a 30, 60, 90 triangle, the smallest side, the side in between 60 degrees and the right angle, is going to be A. We'll just call it A. In this case, 2. The other leg is going to be whatever the smallest leg is multiplied to the square root of 3. The longest side, the hypotenuse, is going to be whatever the shortest leg is multiplied to 2. This is the rule for the 30, 60, 90 triangle. The smallest is whatever it is. To find the other leg, you multiply the smallest leg by the square root of 3. And to find the hypotenuse, you multiply the smallest leg by 2. So, in order to find V, V is going to be the other leg. The smallest leg is 2. So V is going to be the smallest leg multiplied to the square root of 3. And that's it. Don't run your calculator. Don't type it out. We're going to leave it like that. U is much friendlier. U is going to be the smallest leg times 2. So 2 times 2, let me get out my calculator, is 4. So my smallest leg is 2. My other leg is 2 square root of 3, like that. And my hypotenuse is 2 times my smallest leg. 2 times 2 is 4. This is how you use the 30, 60, 90 triangle to find the missing sides. Find the missing side lengths. All right, what we have here is a 30, 60, 90 triangle. There's a little rule that says if you're given a 30, 60, 90 triangle, okay, we'll call you 30 degrees, we'll call you 60, and you're going to be my 90. You find out what the smallest leg is, call it A. The other leg is going to be A times the square root of 3. The hypotenuse is going to be 2 times A. That's how you deal with the 30, 60, 90 triangle. It's a shortcut, okay? Those of you who are using this video as a refresher, if you're thinking, oh, I'm going to use SOHCAHTOA, don't. You could, but don't. If you have no clue what SOHCAHTOA is, pretend I didn't say that. Now, what do we have? We have the hypotenuse. We're not starting out with the smallest side, okay? That is my smallest side. That is my A. Okay, so I'm working my way backwards. Well, let's use common sense. Okay, if the longest side, the hypotenuse, is 2 times the smallest side, then in order to find the smallest side, we go in reverse. Divide 16 by 2, which according to my brain is 8. And you're thinking, oh, this isn't bad. I can find x easily. Hold your breath a little bit because this one's not going to be so pleasant. Actually, I take it back. I now have the smallest side. I have the smallest side. The smallest side is 8, which means to find the other leg, all I have to do is multiply the smallest side by root 3. So I'm done. What I was initially thinking is I was going to take that 16, divide it by root 3. And you might be thinking, isn't it bad to divide by square root? It is, because you have to do all these little extra rules called rationalizing the fraction, but we didn't have to do that here because I was a little more clever. Again, what I did is I was given the hypotenuse. I know the hypotenuse is 2 times the smallest leg, so the smallest leg is half the hypotenuse. Dunzo. Y is 8. Once I have the smallest leg, I know that the other leg is just root 3 times the smallest leg, so root 3 times 8 is 8 times root 3. And if I wanted to, I could have found x by dividing by root 3, which would require me to do a little bit of extra work, but didn't, so I'm done. Find the missing side lengths. What I have here is a 45-degree angle and a 90-degree angle And common sense tells me you're also going to be 45 degrees. This is a special triangle called the 45-45-90 triangle. 45-45-90 gets its name from the fact that I have a triangle with a 45-degree angle, another 45-degree angle, and a 90-degree angle. The legs here, since this is an isosceles triangle, are exactly the same. So I'll call you A and I'll call you A as well. The hypotenuse, if you're thinking, oh, I'll just do Pythagorean Theorem, don't worry about it, because after you do Pythagorean Theorem, you're just going to multiply the square root of 2 to the smallest leg. That's kind of the trick. That's why this is a special case right triangle. So over here, I have a leg of 2 times the square root of 2. Well, if one of my legs is 2 times the square root of 2, that means B, the other leg, is also going to be 2 times the square root of 2. Bada bing. Now to find the hypotenuse, which is A, I'm going to take my smallest leg, both of these are the same, so they're both the smallest leg, and I'm going to multiply it to the square root of 2. So the square root of 2 times the square root of 2 means you can multiply inside the square roots and get the square root of 4. Oh, I know what that is. The square root of 4 is 2, which makes A equal to 4. So this is a special case triangle. It's a 45-45-90. And when you have a 45-45-90, whatever one leg is, the other leg is also. And to find the hypotenuse, you just multiply a leg by the square root of 2. And in our case, we had to do a little bit of clever math, but it really wasn't that bad. And we're done. Find the missing side lengths. All right, I have a triangle. That's 45 degrees. That's 90 degrees, which means you're 45 degrees as well. Now, this is a special case triangle called the 45-45-90 triangle. It's called 45-45-90 because the angles are 90 degrees, 45 degrees, and again 45 degrees, which means it's isosceles, which is good because whatever one leg is, the other leg is exactly the same. If I'm given a leg, what I can do to find the hypotenuse is take that leg and multiply it to the square root of 2. So if you're thinking, this is pretty simple, just take a leg and multiply root 2 to it to get the hypotenuse, I'm done. Great, except this one's not that simple. See, I'm given the hypotenuse. I need to find both legs. X and Y are going to be the same thing. So once I find X, I have Y. The problem is I'm starting out with a hypotenuse. So if I'm given a leg and I multiply square root of 2 to get the hypotenuse, then in order to get the leg from the hypotenuse, I divide by the square root of 2 because I'm working in reverse order. Now, when you have a square root and you divide by a square root, we can shove 2 off to the side and divide both of these guys within the single square root. So you get 6 divided by 2 inside the square root. Last time I checked, 6 divided by 2 is 2 times the square root of 3. And so my X and my Y are both going to be 2 times the square root of 3. So there are times where you use special case triangles like this one, and you're given the leg, and it's easy. When you're given the hypotenuse, you have to work in reverse, which means you divide by the square root of 2. And in our case, it still ended up being a fine number. If you're like, oh, let me whip out my calculator and find out what that is, don't. Okay, whenever you're dealing with right triangles, you're going to see square roots quite often. Don't lose sleep over it. I certainly won't. Neither should you. Find X. All right, there you are. Let me see. I have 2 triangles attached to each other. X is way up here where the only information I'm given is 90 degrees and 45. Oh, that makes you 45. Great. But that's not enough information to give me any lengths here. So let me go to this other triangle, which is 45 and 90. So you're 45. Okay. Now, there's a little rule when you're given triangles that are 45, 45, 90 that we can use, and that uses the special case triangle 45, 45, 90. The 45, 45, 90 triangle says that if you have a triangle where your angles are 90 degrees and two 45s, if I give you a leg, we'll call it A. The other leg has to be the same exact thing because this is an isosceles triangle, which means these angles are the same and the legs are the same. In order to find the hypotenuse, you take the leg and you multiply root 2 to it. So whatever this leg is times root 2. So I have one length here and it's 7. So since this is 7, just for funsies, I will say that that is 7. Does that help me? No. What will help me is the fact that this will be the hypotenuse of this bottom triangle here. That's the hypotenuse. 45, 45, 90. The hypotenuse is square root of 2 times a leg. So you are 7 root 2. Done? Nope. Because my next step is, now that I have that little piece of information, I could use this triangle right here and find my missing hypotenuse. So if you're 7 root 2, just for funsies, I can say that you're 7 root 2. Does that help me? No. But what I do know is that this is a 45, 45, 90. And according to the 45, 45, 90 rule, if whatever one of the legs are, I just multiply it to root 2. So x, my hypotenuse, is going to be one of the legs, that's the leg, times root 2. So I have 7 times the square root of 2 times the square root of 2. If you're multiplying two square roots together, just multiply the insides and keep that square root there. So 2 times 2 is 4. I know what the square root of 4 is. It's 2. And I know what 7 times 2 is. It's 14. So x is 14. Any units? Nope. So that's my guy. So I use special case triangles to find the missing side when I'm given two triangles glued together. Fun. Find x. There you is. What do I have? I have a big triangle, this triangle glued to that triangle. All right, I have 9 root 6 and x is way over here. So x isn't attached to 9 root 6 really in any way whatsoever. What do I know? X is attached to a triangle that has a 90-degree angle and a 60-degree angle, which means you're a 30-degree angle. Oh, I'm probably going to end up using the 30, 60, 90 triangle. So let's draw that out. 30, 60, 90. The 30, 60, 90 triangle says that if I have a triangle with a 90-degree, a 30-degree, and a 60-degree, whatever the smallest leg is, I'll call you A, the hypotenuse is going to be exactly 2 times that smallest leg. The other leg is going to be the square root of 3 times the smallest leg. So what I'm going to do is I'm probably going to end up using those facts for this guy, but I can't even begin this guy until I figure out what I have over here. My 9 times the square root of 6 is attached to this leg of this right triangle that has an angle of 60 degrees. So that means you're 30 degrees as well. So this is the longer side of a 30, 60, 90 triangle. So what I have to do is work backwards a little bit. I have to work backwards to find this guy right here. I'll call you A. A, in my case here, represents the smaller leg of this right triangle. Now, if I were to find the bigger leg of a right triangle that's 30, 60, 90, I multiply by root 3. So if I wanted to work in reverse and say, let's now go from the big leg to the small leg, that means I have to take 9 root 6 and divide by root 3. So again, I called A, this leg right here. You are now 9 root 6 divided by root 3. 6 over 3 is doable, so what I'll do is I'll just move the 9 off to the side. There's a rule that says if you're dividing square roots, just make it one big square root and divide on the inside. So 6 over 3 inside the square root. 6 over 3 is 2. So that length right there is 9 root 2. 9 root 2. This is not going to be pleasant at all, because now I have part of this guy right here. Now I'm looking at my smaller right triangle right here. Gross. Can't draw at all. So what I can do is let me redraw it, make it a little bit bigger, make it a little bit more pleasant to look at. You're 90, you're 60, you're 30. You are now 9 root 2. I need to find you. I don't know you. So just like this guy, I'm given the larger leg. And in order to find the hypotenuse of a 30, 60, 90 triangle, I have to deal with the smaller leg. I have the larger leg. If I'm given the larger leg and I have to find the smaller leg, what do? Let's call it B just for funsies. B is going to be 9 root 2 divided by root 3, just like we did up here. There's a problem, though. I could do 6 over 3 and make it go away. I can't do 2 over 3 in roots. So what I have to do is I have to rationalize the denominator, rationalize the fraction. I have to get rid of that square root of 3 because you're not allowed to have square roots of 3 in the denominator of a fraction. So the way you get rid of it is you multiply the top and the bottom by the square root of 3. This is going to make you happy. You'll see why in a moment. Okay. B is going to equal 9 times the square root of 2 times the square root of 3, which is the square root of 6. When you're multiplying square roots, you multiply within the roots and make it one bigger root. The square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3. So B is 9 root 6 over 3. 9 and 3 don't have square roots. So I can simplify 9 divided by 3 and make it just 3 root 6 because 9 over 3 is 3. So this guy, my smaller side, my smaller leg is 3 root 6. So if I have a 30, 60, 90 triangle and my job is to find the hypotenuse and I have this smaller leg, I'm finding x now, I take this smaller leg, 3 root 6, and multiply it by 2. 2 is outside the square root, so is 3. So 3 times 2 is 6. X equals 6 root 6. No units, nothing like that. We use special right triangles in order to find missing parts of two right triangles glued together. Fun, 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 fun. Find the value of the trigonometric ratio as a fraction. So we're given this right triangle. All three sides are given to us. I have angles too, but no information about that except the fact that you're 90. And it's asking us to find sine of C. That's not sin C. That's in Ohio. Cincy? Cincinnati? Anyway, so if you're ever asked to find sine C or cos C or tangent C, you are going to use this little acronym, TOA. Now, what we do is we take a look at the angle that we care about and we look at the sides compared to the angle. For example, 35, no matter what's the hypotenuse, 28 is going to be opposite of C, and 21 is next to it, which means adjacent. So SOHCAHTOA tells us, look, if you're using sine, you care about the opposite and the hypotenuse. If you're using cosine, you care about the adjacent and the hypotenuse. And if you're using tangent, then you care about opposite over adjacent. Now we're using SO. And SO means the sine of whatever angle you're using, in this case C, is going to be the opposite side over its hypotenuse. Okay, so the opposite side, according to C, is 28. 35, no matter what, is your hypotenuse. So sine C is going to equal the hypotenuse on the bottom and the opposite on top, 28 over 35. And that's it. That's just the trigonometric ratio. I can't do anything with that, can't simplify it. We're going to leave it like that. And it says leave it as a fraction, so we're going to leave it as a fraction. So sine of C in this case represents 28 over 35. Find the value of the trigonometric ratio as a fraction. So we're given a right triangle. All three sides are there. No information about the angles except that's 90. And we're being asked to find cosine of C, not cos, cosine of C. Whenever you're asked to find sine of something or cosine of something or tangent of something, you use the little acronym SO, CA, TOA. What that does is it tells you, look, if you're finding sine or if you're finding cosine or if you're finding tangent, you care about either opposite sides, a hypotenuse, or an adjacent side. Now, if we take a look at C, okay, I'm being asked to find the cosine of C. I'm using this one because this is saying the cosine worries about the adjacent side and the hypotenuse. So I care about finding cosine C. Now, if I'm asked to worry about the adjacent side, according to C, means the side next to it that's not the hypotenuse. 27 is right next to it. The hypotenuse is 45. Don't be like, oh, well, 45 is adjacent too. Yeah, it is, but 45 specifically is the hypotenuse. So this stands for cosine of your angle equals the adjacent side over the hypotenuse. Adjacent over the hypotenuse. In other words, cosine of C is the adjacent side, which is 27 over 45. Now, in this case, it looks like I can divide both of these by 9, so I can simplify this further and say that cos C is 3/5. Now, depending on the teacher that you have, they might not care about that. They might just be happy that you notice that it's 27 over 45. But if you notice that you can simplify it, simplify it. But there we go. There we go. There we go. Like and subscribe. Find the value of the trigonometric ratio as a fraction. Tans. That's what I get in the summer. What we have here is we have a right triangle. All three sides are given. 90 is given. Nothing else, though. No other angles. But we are being asked to find the tangent of angle Z. Now, if you're asked to find a trigonometric ratio, you are going to use this clever little phrase, SO, CA, TOA. Now, what this does is this tells you, listen, if you're trying to find sine, you're going to use this one. If you're trying to find cosine, you're going to use this one. If you're trying to find tangent, you're going to use this one. We're trying to find tangent, so we're going to use this one. Now, there's multiple things that we need to worry about here. I care about Z, this one Z. Okay, that's my Z angle. Now, what TOA stands for is the tangent of whatever angle you are trying to find has to equal O and A. What is O and A? O stands for opposite, and you always put it over the other letter, which is adjacent. So this would be adjacent over hypotenuse, opposite over hypotenuse. But in this case, we're trying to find the tangent, which is opposite over adjacent. So if you're like, well, what's opposite over adjacent? Well, we compare the opposite side and the adjacent side to Z. So the opposite side is going to be the side opposite of Z, which is 21. The adjacent side is going to be the side next to it. And if you're thinking 35 and 28 are both next to it, yeah, but 35 is a hypotenuse. We want the side next to it that's not a hypotenuse. So not you and yes, you. So the way we set this up now is we say, all right, tan Z is going to equal the opposite side, which was 21, over the adjacent side, which was 28. And you might notice 21 over 28, does that simplify? It sure does. 28, 21, divide them both by 7 3/4. And that's my answer. Tan Z is 3/4. I've heard of Gen Z, but tan Z, that's all we're trying to find here. Find the value of the trigonometric ratio as a decimal. We're given 3 right triangles, and we are being asked to find 3 ratios as a decimal. Whenever you're asked to find the trigonometric ratio, you are going to use this cute little phrase, SOHCAHTOA. Now, SOHCAHTOA means if you're trying to find sine, then you have to worry about the opposite side and the hypotenuse. If you're trying to find cosine, then you worry about the adjacent side and the hypotenuse. If you're trying to find tangent, then you worry about the opposite side and the adjacent side. Let's do one at a time. All right, sine of Z, there's my Z. When you do sine of Z, you care about sine Z equals the opposite side over the hypotenuse. Now, let's do one thing at a time, hypotenuse. Now, we compare Z with these numbers. We're going to say, all right, well, if you're just looking at this and not really worried about the letters and you're like, well, which one's opposite, which one's adjacent? Look at Z. The opposite to Z is 30, so my opposite is 30. My hypotenuse is always 50 because 50 is going to be opposite of the right angle. 30 over 50 simplifies to 0.6. So sine Z is going to be 0.6 in this one problem right here. You know what? Jesus died for that. Our sins. Cosine Z. All right, so there's a new Z right there. And cosine is going to use co, which I believe is slang for friend. Now, cos Z has me caring about the adjacent side, adjacent means next to, over the hypotenuse. So if you look at Z over here, and if you're thinking, isn't 12 and 15 adjacent? Isn't 12 and 15 both next to Z? They sure are. But 15 is the hypotenuse, which would make 12 the adjacent side. Now, 12 over 15, this fraction is not near as friendly as this, but if I notice that both of these are divisible by 3, that becomes 4 over 5. And I know 4 over 5 is the decimal 0.8. So cos Z is going to be 0.8. Let's get a new color and do a new problem. Tan X. Now tan X, where's my X? There you is. Tan X is going to use TOA. So tangent X is going to be the opposite side over the adjacent side. Okay. Now, looking at X, the opposite side of X is 30. I can handle that. I have two adjacent sides, 40 and 50. Oh, but 50 is opposite of the 90-degree angle, which makes 50 my hypotenuse. So my adjacent side is going to be 40. 30 over 40 is the same as saying 3/4, and I know 3/4 is 75 cents. So that's what tan X is. Lots of puns in this one. I like it. I enjoy it. Hopefully that gets me more than 10 views. But yeah, there they are. Trig values written as decimals. Fun, fun, fun. Find each angle measure to the nearest degree. What they're asking us to do is find each of these 3 letters. Here's the problem for each of these 3 letters. There is a trig function in the way. Sine is in the way, cosine is in the way, tangent is in the way. So I have to get rid of each of these trig functions legally. Now, the way I do that is I use the inverse trig function. So what I'm going to do is I'm just going to rewrite this guy, give myself some space. I'm going to have to do that with all three of these. Okay. And I'm definitely going to need a calculator for this one. You guys can't do these on your own. Back in the day, people had to use slide rules. Those were a nightmare. Now, my issue currently, all I did, by the way, was rewrite that. My issue currently is sine is in the way. You can't divide sine from both sides. What you do is you take what's called the inverse sine. Some people call this the arc sine. Same thing. Inverse sine. What the inverse sine does to a regular sine is it gets rid of it. Okay, so now b is all by itself. The problem is I have to go to a calculator and find out what the inverse sine of 0.4848 is. So if you're using like a TI-84 Plus, you're looking for that inverse sine button. If you're using Desmos, you have to hit functions and use that button. So I'm actually going to go off to the side here, use my Desmos, and I'm now typing in, I'm not typing in anything. I'm hitting the inverse sine of 0.4848. Make sure your calculator is set to degrees. There's something called radians that looks like RAD. You don't want that. Even though it sounds cool because it's rad, you don't want that. Now, I typed it in my calculator, and I actually think I'm set to radians. I am. So I made it degrees. And according to this, I have 28.999, and it wants me to round it to the nearest degree. So 28.999 is 29 degrees. Okay? So what that means is if I were to run to a calculator and type out what's sine of 29 degrees, I would get 0.4848, blah, 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 blah. It's never going to be a nice number most of the time, unless you're dealing with like zeros and 90 degrees and stuff like that. But most of the time, it's going to be very unpleasant. I'm going to write this guy again, cosine A, leave myself some space, 0.7431. In order to get rid of cosine, I have to inverse cosine. Some professors, some teachers call that arc sine. Inverse cosine, both sides. That crosses the coses out. And I run to a calculator. I type out inverse cosine of 0.7431, and I get 42.0038, so I'm going to go with 42 degrees. Okay? Same thing here. All right, I'm going to write out tan W equals, give myself some space, 19.0811. In order to get rid of tan, I'm going to inverse tan both sides. So inverse tan. That gets rid of tan. Some people call that arctan. And now W is going to equal whatever the inverse tangent of, what was it, 19.0811. I get 86.99999. 86.99999 is awfully close to 87 degrees. Now, I am on an iPad using a Desmos app. Make sure, whenever you're in geometry class, pre-calc is a different story, but when you're in geometry class, make sure your settings, like you might have to hit that little wrench thing, make sure your settings are set to degrees. Okay, it says it right there. If you use radians, you're going to get a very small number every time for this. Maybe not too small for that, but you're going to get a very small number. If you're using like a TI-84 or like a Casio or some kind of smart calculator, graphing calculator, it might say something like rad next to degrees. Like if you hit the mode button, it'll probably say rad in degrees. You want the degrees. Okay, so make sure your calculator is set. But that's how you do it. If you are told sine of an angle equals stuff, inverse sine it, inverse cos it, inverse tan it, and you'll get that. Dunzo. Use SOHCAHTOA to find the missing angle. I'm going to call this angle x just for math's sake, and I'm supposed to find that missing angle. Well, I have a right triangle. That's extremely important. I don't have the other angle, but I do have two sides. It's telling me to use SOHCAHTOA. So this is what I'm going to do. I'm going to take a look at x. 42 compared to x is my hypotenuse. 40 compared to x is the opposite side. So I am going to choose the three of these that involve the hypotenuse and the opposite side, and it's u. So what I do whenever I'm using SO is I get a needle and thread. I say sine of my angle, which I called x, is going to equal the opposite side over the hypotenuse. Okay, so I don't know x. So sine x equals the opposite side, which is 40, over the hypotenuse, which is 42. Excuse me, math teacher Goat, you left a whole lot of space there. Is there a reason? Yes. I have to find x. X here represents the angle measure. Sine is in the way. So just like Christ did for us, I have to wash this sine away by inverse sining both sides. In order to get rid of the sine, you inverse sine both sides, and that cancels out the sine on the left. The problem is I have to find out what inverse sine of 40 over 42 is, which I have zero clue. So you always, not always, but most of the time in geometry, you're going to have to run to a calculator, which I'm on my iPad. I'm on Desmos right now, and I'm typing out inverse sine of 40 over 42, and I get 72.2472. So I'll write all those out, 2472. Now, this is an angle measure. X is nowhere in the original problem, so I'm not going to circle this for two reasons. Again, because X is nowhere in the original problem and I don't have my degrees. So I'm going to write out 72 point, and if you want to round this to 2 decimals, fine, 25 degrees. But that's my missing angle measure. Okay? And I use SOHCAHTOA to do it. I had to do inverse trigonometry to do it, and I landed on that guy. Again, when you have to use a calculator, make sure your calculator has a mode set to degrees, which means if you're using like a TI-84 Plus or something like that, you hit mode and you make sure it's in degrees. If you're using Desmos, you click the little wrench looking thing and make sure it's set to degrees. Otherwise, it's going to give you a completely wrong number. But that's the right number, and I'm happy. Use SOHCAHTOA to find the missing angle. First things first, you're being asked to find the missing angle, and I know if we have to use SOHCAHTOA, we're going to need a calculator. So make sure your calculator is set to degrees. So if you're using Desmos, you're going to hit the little wrench and set it to degrees. If you're using a graphing calculator, make sure you go to mode and set it to DEG and not RAD. All right, I'm being asked to find this question mark right there, and I'm going to call it X. I'm given a right triangle, and I'm given 20 and 13. Now, I have to compare 20 and 13 to X. 20, no matter what, is my hypotenuse. 13 is right next to X, which means 13 is going to be my adjacent side. No opposites here. So, just like if I were calling my friend, I'm going to use ka, because ka is slang for friend. Ka is cosine of your angle equals the adjacent side over your hypotenuse. So according to what I have, I'm going to write out cosine of the angle that I need to find, which I did call X, is going to equal the adjacent side, which is 13, over the hypotenuse, which is 20. If you're thinking, wow, you sure unnecessarily left a whole lot of space here, I did leave a whole lot of space, but not unnecessarily. My job is to find x, that missing angle. Cosine is in the way. The way you get rid of a trig function is you inverse trig both sides. So I'm going to inverse cosine that guy, and I'm going to inverse cosine that guy, which is definitely going to require that calculator I was talking about. The inverse cosine and the cosine cancel each other out. I run to a calculator, and I type out the inverse cosine to the -1 of 13 over 20, which I'm using Desmos. My Desmos says 49.4583, blah, 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 blah. If you get a really small number. Now, by the way, if I look at this, you're never supposed to look at a picture and say, yeah, that looks right. But it does look right. That does look like it's in the 40s as far as angles go. If you never set this to degrees and it was set to radians, it would give you a very, very, very small number, and you would know that you're wrong. Set it to degrees. Now, I'm not done yet for two reasons. First off, I never used x in the original problem. I created x, so I don't need x. Second, this is an angle, so I have to put degrees, and I am going to round this to 2 decimal places. So my final answer is going to be 49.46 degrees. That's my guy. All right. So in this case, x, 20 and 13 were my hypotenuse, and my adjacent, which is a and h. Use cosine, use inverse cosine, type it in your calculator or Desmos or whatever it is that you're using, and you're good to go. Use SOHCAHTOA to find the missing angle. So I have to find that angle right there. I'm going to call you x. Now, whenever you're doing right triangle trigonometry, and that's what this is, because SOHCAHTOA stands for sine, cosine, and tangent, which is trigonometric functions, you have to always use a calculator. Not always, but like 99% of the time. Make sure if you're using Desmos, you hit the little wrench and have it set to degrees. If you're using a graphing calculator or a scientific calculator, make sure it's set to degrees and not radians. Radians are something completely different. You'll find out in pre-calc. Now, I'm looking at this missing angle here that I called x. I have no other angles, so it's not like I can subtract from 90 or 180 or anything like that. That's no good. So I have to use these two sides right here. What I have to do is compare 27 and 38 to x. Now, the obvious one is 27 is opposite of that. 38 is next to it. So is that my adjacent or is that my hypotenuse? Well, this is my hypotenuse, so you're my opposite for sure, and you're my adjacent for sure, and I don't have information about the hypotenuse unless I wanted to do Pythagorean Theorem, but that's a waste of time. So opposite, adjacent, TOA. Now we're going to set up what TOA means. TOA means the tangent of an angle is going to equal the opposite side over the adjacent side. Okay, so here I have tangent of x equals the opposite side, which I called 27, over the adjacent side, which I called 38. Wow, I sure left a lot of space there, didn't I? I did, and I did that on purpose because I have to get x all by itself. And the only way you get x all by itself is to get rid of that tangent. So we get rid of tangents by taking the inverse tangent of both sides. So we write out the inverse tangent of both sides. That allows us to cross out those tangents over there. Now x is all by itself. I am running to my graphing calculator right now. And if you're using Desmos, you hit functions. If you're not, if you're using a graphing calculator, you probably have to hit second tangent. And then the little tangent inverse pops up. And then you type out 27 over 38. And according to the Desmos that I'm using, I get 35.934795, blah, 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 blah. Now, I'm not done. I'm not going to circle that for two reasons. Reason number one, I never used x in the original problem. I created x just because. Also, I don't have a decimal, and that's just that's too many numbers. So I'm going to round this off to 2 decimal places and say that my answer is 35.39 degrees. All right. And you could look at this and say, yeah, that looks about right. If for some reason you did this and you got a ridiculously small number, that's because you have it set to radians. And that's not rad. It's 90s slang for really cool. Find x using SOHCAHTOA. All right. I have a right triangle. I have x, which represents what looks to be a hypotenuse, so I'll label you hypotenuse. I have an angle right here, and I have a side, but that's all the information I have. So it's not like I'm given another side I can do Pythagorean Theorem. I have the angle, I have 2 sides, and that's it. Well, SOHCAHTOA helps us when we only have 2 sides or only need 2 sides and we're given information about an angle. So I'm looking at my angle 72 degrees and I'm comparing what x is to 72 degrees. Well, I already said it's my hypotenuse. So what is 6? 6 is directly next to my angle, which is my adjacent side. Now, before you're like, well, isn't x also adjacent? It is, but that's my hypotenuse. And stop talking like that. So I need to choose the one of these that uses the adjacent side and the hypotenuse. And why don't I call my friend or my Paul Walker one time said that in Too Fast, Too Furious like 20 years ago. He's like, forget about it, If you've seen it, you know. All right, so if we're using we are going to set up cosine of my angle, which I'll call A because I'm afraid to call it X, is going to equal my adjacent side over my hypotenuse. And now I plug in what I know. I plug in cosine of my angle, which I know my angle. We did previous videos where we didn't know my angle, but now I do. Is going to equal my adjacent side, which I know is 6, over my hypotenuse, which is x. So in a previous problem, I was trying to find the angle and we needed to use inverse cosine, not here. What I do is I run to whatever calculator I have or Desmos or whatever I have and make sure your calculator is set to degrees. So if you're using Desmos, hit the little wrench thing and go to degrees. If you're using like a TI-84, make sure you go to mode and make sure it's in degrees. And you're literally going to type out cosine of 72, which I am actually doing that this very second. It's giving me the fraction 0.30901, so I'll just call it 0.309. That's going to equal 6 over x. My job is to solve for x, so this is what I'm going to do. X is on the denominator. I don't like that, so I'm going to create a denominator for you and look at this out of proportion. You don't have to do it this way. This is just the way I'm doing it. And if you don't like it, watch like friggin' Khan Academy or something. They're just not cool and funny. Whenever you have a proportion, crisscross applesauce. So I'm going to multiply 0.309 to x, which is 0.309x. And you're going to set that equal to 6 times 1, which according to my calculations is just 6. You divide both sides by 0.309, divide both sides by 0.309. So I'm actually going to type that out right now. 6 divided by 0.309, and I get 19.41747. So depending on how picky, I mean, I didn't tell you where to round it to, so let's round it to 2 decimal places. 14.42, no units to worry about, don't have to worry about inches or feet or anything like that. So that's how you find x. We're finding a hypotenuse using trigonometry. Awesome. Find x using SOHCAHTOA. So SOHCAHTOA means like trigonometry stuff, sine, cosine, tangent. I'm given this right triangle here, which is the only times I can use sine, cosine, and tangent in geometry. And I have to find a missing side. Not find an angle, find a missing side. I have an angle, and I'm going to compare these sides to that angle right there. X compared to 37 is an opposite side. 12 compared to 37 is adjacent, and the side that I don't care about is a hypotenuse. So I need to pick the guy that cares about opposite and adjacent, and that's TOA. So what TOA stands for is tangent of an angle equals the opposite over the adjacent side. Make sure when you do this, your calculator or Desmos is set to degrees. So go to mode or go to that little wrench thing and make sure you're set to degrees. But I'm going to set this up according to this. Tangent of my angle, I have my angle, it's 37, is going to equal my opposite side, which I don't know, over my adjacent side, which is 12. Do you know what tangent 37 is? I don't. I doubt you do. So I'm typing it in a calculator right now. Tangent 37, according to Desmos, is 0.753554. An unnecessary amount of decimals, but I always like to write more than I need. So tan 37 turns into that. Nothing happens on the right side until now. Is x all by itself? No, it's not. 12 is being divided from it, but this is just an Algebra 1 problem. Multiply both sides by 12. So I'm going to take that ugly number that my calculator has. I'm going to multiply 12 to it, and I get 9.0426 blah, blah, blah is going to equal x. So let's flip this around, clean it up a little bit. X is going to equal, let's round to 2 decimal places, so it's not 5 or above, give it a shove, 9.04, leave it as that. That is my X. Looking at the picture, that looks like it would make sense. I don't have to worry about feet or inches or units of measure here. There you have it. There you have it. Just make sure when you do these, you have your calculators, or make sure Desmos or whatever it is that you're using is set to degrees. Otherwise, you're going to get terrible answers. If TRS is a triangle, so let's draw that out. TRS is a triangle. Of course, not drawn to scale at all. I didn't even look at the numbers. If the measure of angle S is 118 degrees, and if little s, which is going to be over here because it's opposite of S, is 16 feet, and if little r, which is going to be over here, is 5, find this angle right here. So I have big S, little r, I need to find big R. Whenever I have 2 of the same letter and 2 of the same letter, but I need to find a missing letter, I'm going to use the law of sines. So let's set that up. The law of sines says that the measure, or the sine rather, of an angle, so let's just choose an angle, big S, over its opposite side is going to equal the sine of the other thing that I care about, big R, over its opposite side. So let's plug stuff in. Sine of big S is going to be sine of 118 degrees. Over its opposite side is going to be 16. That's going to equal the sine of big R, which is, I don't know, over little r, which is 5. Whenever you have a proportion, a fraction equaling a fraction, you do a little bit of crisscross applesauce. So I'm going to do that. I'll write it over here. That gives me 16 sine r equals 5 times sine 118 degrees. 16, can't do anything with it. Sine r, can't do anything with it. But I can type all of this into a calculator. And when I do, I get 4.41473. 4.41473. A lot of decimals, but who's counting? Now, in order to get sine r all by itself, I have to divide both sides by 16, like so. So sine r is going to equal, leave some space, 0.2759. Now, my job is to find r. I don't have that yet. So I'm going to inverse sine both sides. Inverse sine both sides. When I run to a calculator and inverse sine this decimal right here, I end up with 16.0169 nice degrees. And that's my guy. That's all I have to do. The measure of angle A is 64 degrees. The measure of angle B is 98 degrees. A is 29, and I have to find B. Whenever I'm given a problem like that, when it gives you capital A and lowercase a, I'm thinking this could have to do with any triangle. Little a is going to be opposite of angle A. Little b is going to be opposite of angle B, and if I had a C here, then I would use C. Now, I don't have that. I'm supposed to find B. Now, obviously, I don't have a ton of information, but whenever you're given two angles and a side, or two sides and an angle, and you need to find the missing whatever thing that's missing, so I have A, B, B, so they come in pairs, almost like a proportion. I'm going to use what's called the law of sines. Now, the law of sines says that sine of an angle over its opposing side equals a sine of an angle over its opposing side equals sine of the third angle over its opposing side. Now here I don't need that much information. The letters kind of line up nicely. But once I have enough information where I have a pair of stuff and a pair of stuff where one of those things is missing, I could just set up whatever letters work for me and do sine of one angle over its opposite side equals sine of the other angle over its opposite side and go from there. So I have all my letters working out for me. Sine of 64 degrees over its opposite side, which is 29, is going to equal the sine of 98 degrees, boy band from the 90s, over, I don't know. So whenever I have a proportion, a fraction equals a fraction, you use the good old crisscross applesauce method. So I have 29 times sine of 98 degrees is going to equal B times sine of 64 degrees. Okay, I did this ahead of time to save a little bit of time. 29 sine 98 when multiplied out is 28.7178. B is still B, so I'll put B over here, just to keep it look nice. Sine of 64 degrees is 0.8988. In order to get B all by itself, I divide both sides by 0.8988, divide both sides by 0.8988, cross U out, and B ends up being 31.9513 miles. So whenever I give you a triangle, okay, and you have two pairs of things and you're missing one of them, that's when you use the law of sines. Okay? And that's what we did. Not pretty, but neither is your mom. Just kidding, your mom's fabulous. Like and subscribe. Find the measure of angle R. If I give you a triangle and I give you all three sides and it has nothing to do with a right triangle and you're trying to figure out what your missing angle is, you are going to use the law of cosines. The law of cosines, which says c squared, which is a side, equals another side plus another side, both of those squared, minus 2ab cos big C. Now, what's big C compared to little c? Big C is the angle opposite of this side right here. So in this case, R is my big C. R is my big C, which means I want to make you my little c. I don't care which one's A or B. So when I set this up, I'm going to be doing 28 squared. Again, whatever you have, whatever angle you're looking for, it's equaling that side squared. That's going to equal, it doesn't really matter which one's which, 18 squared plus 12 squared minus 2 times 18 times 12 times cosine of, I don't know. Let's do a little bit of math. 28 squared becomes 784. Let's do both of these. 18 squared plus 12 squared is 468, sorry. Minus 2 times 18 times 12, let's do all of that math right there, and that gets me 432, still attached to cos R. Right now, this is just a gross-looking two-step equation. Subtract 468, that's supposed to be a 6. Subtract 468, cross U out. That gives me 316, John 316. That equals negative 432 cos big R. Not done yet. Divide everything by negative 432. Divide everything by negative 432. That crosses U out. So let me get a different color. Let me move stuff off to the side. I have cos R is going to equal negative, and let me move that over there, negative 0.7361. In order to get R all by itself, I'm going to inverse cosine both sides. Definitely throw that into a calculator. But what you get is the measure of angle R. And the measure of angle R is 137.4 degrees. And now that we're supposed to look at these pictures and say, oh yeah, that looks like it could be right. But yeah, that looks like it could be right. That's a pretty big angle. Pretty big angle. Just like Kurt Angle. He was a wrestler. Look him up. Big dude. Like and subscribe. Find ST. Now, ST is this guy. We'll also call it little r. Now, usually we do the law of sines, but the law of sines says that if you have like two angles and a side and you can pair things up, then you use the law of sines. However, I don't have that. If you're given two sides and you're missing two angles, it'll be an absolute nightmare to use the law of sines. So we are going to use what's called the law of cosines. The law of cosines is best used, again, if you have two sides and only one angle, or if you have all three sides and you need to find some missing information about your angles. In this case, I have two sides, one angle, law of cosines. What is it? C squared equals A squared plus B squared minus 2AB cos big C. So if you're thinking Pythagorean thoughts, you're thinking right. A, B, and C are all sides, and big C is the angle opposite. So this would be like my little c, you would be like my big C, and you can be A or B. It doesn't really matter which is which. My job is to find R, which I'm calling C. So R squared is going to equal, if I call you A and if I call you B, that'll be 12 squared plus 16 squared minus 2 times 12 times 16 times cos 54. The nice thing about all of this is it's all one big terrible calculator problem. And when I throw that into a calculator, I get 174.2905. Am I done? No. In order to get r all by itself, I have to square root everything. And the square root of that terrible number is another terrible number, 13.202. Any units? Nope. But there you have it. Law of cosines is useful when I'm finding a missing side when I only have one angle but two other sides. Okay? Dunzo. Find x using SOHCAHTOA. All right, so x is over here. I'm given a 30, 60, 90 triangle, and Satan is tempting me to use that, but I'm not going to. Maybe I will. I don't know. Maybe I'll just give in to my temptations. But I can't even do anything right now. If I'm just given a hypotenuse and 60 degrees. That don't help me. But over here on this triangle, I'm given 39 degrees. I'm given 38. That's it. Oh, if only I could find out what that side is. If only I can find out, then I would have a side here, 60 degrees and x, and that would make life a lot easier. So that's what I'm going to do. I am going to look at this triangle right here. I have an angle of 39 degrees. 38 compared to 39 degrees is my adjacent side. I have to find this side. This side, which I don't want to use x, so I'll call it y. This side is opposite of my 39 degrees. So I'm going to use the trig function that involves the adjacent side and the opposite side, and that's TOA. When we set up TOA, we say tangent of my angle is the opposite side over the adjacent side. Tangent, opposite, adjacent. So I'm going to fill in what I know. Tangent of 39 is going to equal the opposite side, which I don't know, over the adjacent side, which is 38. My issue right now is I have zero clue what 39 degrees is. Make sure if you use Desmos, if you use a graphing calculator, you have your mode set to degrees. Otherwise, this is not going to work. So I'm going to go to a calculator right now, and I'm going to type out tangent of 39 degrees, and it's telling me that it's 0.80978. So 809. We'll just make it 9.8 right there. Okay, I'm rounding it a little bit. And that's going to equal y over 38. Okay, tan 39 turned into that. Is y all by itself? No, but it's over 38, and I know from algebra if I multiply both sides by 38, y will be all by itself. So let's take that number that I typed into my calculator, let's multiply it by 38, and it's giving me 30.7717. So I will say 30.77 is y. Now, y is really not called y. I just called it y, so I'm going to get rid of u. And I'm also going to get rid of my words because I don't want to confuse anything. Okay. What I do know is that this is 30.77. I also know that this is a 30, 60, 90 degree triangle, but I'm not going to use that. I'm just going to use SOHCAHTOA again. Okay, I'm going to look at 60 and compare this guy and x to 60. That guy is opposite compared to 60. X is my hypotenuse no matter what. And don't be like, it's also adjacent. Yes, but it's my hypotenuse. So I need the guy that uses my opposite and my hypotenuse, and that would be sine. So the way you set up sine is you say sine of your angle is going to equal the opposite side over the hypotenuse. And now we fill in what we know. Sine of 60 is going to equal the opposite side, which is 30.77 over the hypotenuse, which is x. So let's go to a calculator and type out sine of 60. I do know what it is because I teach pre-calculus, but we're going to type it out anyway. It's 0.866025, so I'll leave it like that. That equals 30.77 over x. Now, x is in the denominator, so I'm going to use this little trick where I'm going to turn this into a proportion so I can do crisscross applesauce. Do I have to do it this way? No, I can multiply both sides by x, but I'm not gonna. I have it set up as a proportion now. And so I'm going to multiply diagonals. So 0.866 x, can't forget that, is going to equal 1 times 30.77. I think I can handle the math for that one. In order to get x all by itself, we divide everything by 0.866, divide everything by 0.866. And let me just do this off the top of my head. Just kidding. I'm typing it into my calculator. 30.77 divided by 0.866, and I get 35.5311. So we will say x is 35.53 because it's 1, 1, and I'm not going to worry about those ones. No units of measure, no inches or anything like that to worry about. I am solving for x, so I'm allowed to say x equals. But yeah, kind of a crazy problem. We had to use SOHCAHTOA twice, but listen, man, I love it. So if I had to use it 50 times, I'd use SOHCAHTOA 50 times. Making these videos, I basically have, so if you appreciate that, smash that like button. Find the area of the entire triangle. There is an area formula, okay, that involves trigonometry. It involves sines, but I'm not going to use that. I'm going to use this area formula right here. Half of base times height. That's a b. Half of base times height. I don't have my height. And you know what else? I don't have my base either. So this problem is just very unpleasant. Now, I'm going to cheat a little bit. All right, and please don't get mad at me. I'm going to cheat a little bit. This guy right here, okay, this guy is a 30, 60, 90 triangle. I know with 30, 60, 90 triangles, whatever my smallest leg is, my hypotenuse is going to be 2 times that, and my second leg, my longer leg, is going to be a times root 3 of that. So if I'm given the smallest leg, multiply it by root 3 and I get the longer leg. I have the longer leg. So if I want to find this height right here, I'm going to divide by root 3. So I'm going to go to my calculator because I'm going to need my calculator a whole lot anyway. I'm going to divide 29 divided by the square root of 3, and I get 16.7431. So I'll put 16.74. 16.74. All right. I'm not going to clear that. I'm going to leave that there. Now, that's great. Now I have my height, but I still don't have the entire base. This is what I do have. I have this triangle on the left. I have an angle. I need to find this. I'll call you x, and I have a side next to it. So I'll call you my adjacent side. I'll call you my opposite side, and I'm going to use SOHCAHTOA. Now, if I have my adjacent side and I have my opposite side, that uses the TOA in SOHCAHTOA. And so you set up tangent of your angle, which is 52, is going to be the opposite side, which is, I don't know, over the adjacent side, which is 16.74. I run to my calculator and I type out tangent 52. Make sure your calculator is set to degrees and not radians. And I get 1.27999. So I'll put 1.28. and that's going to equal x over 16.74. Do I have my x yet? No. But if I multiply both sides by 16.74, I will have exactly what I need, 16.74. Good job giving myself a lot of space, Nick. That's my real name. My real name is not Math Teacher Goat. I just call myself that because I'm trying to get more followers. But what I'm doing is I'm running to my calculator right now. I'm typing out 16.74 times 1.28, and I get 21.426222. So I'll do 21.426. X represented that missing side right there. So let's get rid of it. And now call it 21.426. So let's write this triangle out. Let's draw the exact same triangle. As you can see, it's perfect. I know the height. It's 16.74. I know if I add these two numbers together, I get my entire base. So 21 plus 29 is 40. So this whole thing is going to be 40.426. So to find the area, I use this formula and do A equals half of my base, which is now 40.426, times my height, which is 16.74. I'm not even going to pretend that I know what this is, so I'm going to my calculator right now and I'm typing it out. While I'm doing that, make sure you smash that like button. Make sure you crush the subscribe button. Am I sounding like a YouTuber now? Times 16 point, what was it, 74? 16.74. And I typed out the wrong number. 338.365, so I'll call it 37. I don't have a unit, so I will call it square units. That's the area of this whole thing. Now, there's a way that you can do this a whole lot faster using a calculator and sine and stuff like that, but that's what I did here because that's what I was asked to do. If you want to know how I do it faster, watch the next video on your playlist. And don't forget to smash that like button, please. Give me some of that sweet YouTube money. Use SOHCAHTOA. All right, Km is 10 root 3 Km. All right, this whole thing is 10 root 3. The measure of LMN, which is this guy, is 60 degrees. Find LN. Okay, so what I have is a rhombus. I have to find, at the end of the day, LN. Okay. So I'm going to use the fact that this whole thing is 60 degrees. This whole thing is 10 root 3, the whole thing. But I only want this part of the triangle, which is half of that. So half of 10 root 3 is 5 root 3. Okay, so let me get rid of that 60 because I now don't want that whole 60. I know that this length right here is 5 root 3. You would be 30 because if this is a rhombus, then the diagonals bisect the angles. And I'm going to use this triangle right here to help me find Zn. Once I find Zn, multiply it by 2, that gives me Ln. So I'm going to use that triangle, which was 30 degrees. This guy was 5 root 3. And I need to find this guy. Once I find this guy, that gets me Zn, multiply it by 2, and I get the whole thing. So what do I have? I have 30 degrees. Now, the devil is saying, use special triangles, boy. Use it. It says use SOHCAHTOA, so get thee behind me, Satan. I'm going to use what the rules say I use, because the rules are not meant to be broken. So I have 30. 5 root 3 is opposite of that. No, it's not. It's adjacent. Are you down with OPP? All of that. All of that just to be stupid. All right. 3 root 5 is adjacent. X is opposite. So I need to use the one of these three that deals with adjacents and opposites, and you're my guy. So tangent of an angle is going to equal my opposite side over my adjacent side. Let's plug in what I know. Tangent of 30 is going to equal my opposite side, which is x, over my adjacent side, which is 5 root 3. So tangent of 30. Run to your calculator, make sure it's set to degrees, and type out tan 30. You can hit functions, or you can just hit the tan button in a regular calculator. Tangent of 30 is 0.57735, so I will write that out, 0.57735, and that equals x over 5 root 3. Is x all by itself? No. I have to multiply both sides by 5 root 3. So this is me doing that. That allows me to cancel that out. X is going to equal, now let me run to my calculator again and take this guy and multiply it. So hit the times button, 5 root 3. Wouldn't you know it? I get a perfect 5. It's if God is smiling down on us. Now this is 5 right here. Now again, if we didn't have that, and if you know special right triangles, you would know that if I give you the smaller leg, the longer leg is going to be 5 root 3. So this makes sense. Now Zn is 5. Ln is 2 times 5. So Ln is 10. I made a rhyme. No units to worry about, no inches, no feet, nothing like that. Fun problem. Use SOHCAHTOA, so sine, cosine, or tangent. All right, oh my gosh. TQ is 15. There you are, which means you're also 15. I don't know if that's going to matter, but I'm just doing it. TR, this whole thing is 20. I'm not going to write that out yet. XR is 11. Find the measure of angle XTS. XTS. All right. All right, so this whole thing is 20. This whole thing is 20, which means you're 9. Okay, so this problem is actually not near as bad as I thought it would be. Now, where did I get 9 from? If the whole thing is 20 and you're 11, then you're 9. Oh, 9, 11, never forget. So what I'm going to focus on is this triangle right here. That triangle right there where I'm being asked to find this angle. That's a right angle. You're 9 and you're 15. And I'll call this T because there's a T there. Okay, now if my job is to find angle T and I'm using SOHCAHTOA, I have an angle and I need to see what 15 and 9 are compared to that. So 9 compared to T is right next to it, and it's not my hypotenuse, so it's my adjacent. 15 is my hypotenuse, so I need the guy that cares about the adjacent and the hypotenuse, and it's CH, as Paul Walker once said in Too Fast, Too Furious. What's CH? CH is cosine of your angle is going to equal the adjacent side over the hypotenuse. Now I fill in what I know. Cos T equals my adjacent side, which is 9, over my hypotenuse, which is 15. Wow, I left a whole lot of space there. Stupid me, stupid you, because t is not all by itself. We have to get rid of cosine. And in order for us to get rid of cosine, we take the inverse cosine of both sides, so I needed that space so I could do that. The cosines on the left are gone. Okay, I have to run to a calculator or Desmos or whatever and find out what inverse cosine of 9/15 is. While I do that, make sure you understand that your computer, your whatever it is that you're using, calculator, I'm trying to multitask and I'm doing a terrible job. Make sure your calculator is set to degrees, otherwise it's going to give you a terrible answer. This is probably going to be a terrible answer anyway, but yeah, it's not pretty. 53.1301. So we'll stop at 53.13. And that gives me that angle right there. XTS. So I'll finish this answer by saying the measure of angle STS equals 53.13 degrees. Okay. Use area equals half of little a little b sine big C to find area. Now, I'm given that triangle right here, and you're probably thinking, what's this? What's little a little b sine C? What does that mean? If I were to take just any regular old triangle, and you're going to see this a lot when you get to pre-calculus, your angles are going to be capitalized. It doesn't matter which one's A, which one's B, which one's C in this case. Okay, it doesn't matter at all. The sides opposite of the angles are going to be your lowercase sides. So A is over here, lowercase a. C is right here, opposite of that is lowercase c, and B is right here, opposite of that is lowercase b. So if we're going to use little a, little b, and big C, then we care about side angle side. So it's basically you're using, in a sense, SAS, which I use SAS all the time in my videos, but in this case we're using side angle side to figure this out. Oh look, side angle side. So I can call you little a, big C, and little b. So let me get rid of this, and let's find the area. The area, and I'm not going to use A for area because I don't want to make it look like the A that I just had written out. So area is going to equal 1/2 of A, which I called 8, B, which I called 6. Doesn't matter which one your little a and little b are because you're just multiplying anyway. Sine 87. So I'm literally just going to type this straight into my calculator, this whole thing. Make sure you have your calculator or a Desmos set to degrees, otherwise it's not going to give you a pleasant answer. So 6 times 8 times, I had that backwards, doesn't matter, sine of 87, and it's telling me 23.96710.8, blah, 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 blah. So let's finish this problem out by saying that the area is 23.967 centimeters squared. Okay? So that's using the trig area formula to find the area of a non-right triangle if you're given an angle and two sides, as long as the sides are attached. Done. Fun. Number 1.